And then, Chris, I will turn it over to you.
All right, we'll go ahead and get started here. Good morning, everyone. Do a little countdown. Okay, you should see the title screen right now. So this was a presentation I had given back in the Severe Radar and Severe Weather Conference back in Des Moines back in 2024 last year, and I've updated it, done some pretty good amount of updates, threw some more math at it, more charts, all the great things that us scientists like to see. And we'll look at this year a little bit. Sure enough, you know, the data was pretty interesting for this year. All right, so how did all this get started, and when and why did I do all this? It all started back in 2011 when we had all the big outbreaks of tornadoes and everything. And I didn't know this existed. If you go to the SBC page, you click on the research tab and you scroll down to violent tornado outbreaks. And it has a really nice GUI and interface that does a lot of interesting things. You could do some overlays and everything. I was just messing around when I stumbled on it, and I just started looking at some big historical events, and I was like, wow. Found some things that kind of caught my attention. So why I wanted to do this is like, all right, let's look at more and see if there's any patterns, and we'll throw some math to it. And yeah, I was a little surprised to see what fell out of the data and the research. So historic violent analogs, outbreak analogs. I'm just going to throw up some historical dates, and we'll just kind of look. This is very simple, big picture approach, just pattern recognition, just kind of looking at the upper level jet and the surface features, and all the dots represent the strong to violent tornadoes, and then you can see the tracks there. These were more prolific events back in history, and that's Palm Sunday. And just kind of looking as I go through these, the big super outbreak, see if you see anything that kind of repeats itself from a pattern recognition standpoint. This is closer to home for us in Wichita, Kansas. And sure enough, we had another one the following year, very active for us. And then we all know about the more recent big super outbreak. And then another one in 2011. So I like this quote from Mark Twain: history doesn't repeat itself, but it often rhymes. When we look at all those historical analogs, those big violent outbreaks, there was definitely some rhyming going on with the pattern recognition. And that's what caught my attention when I stumbled on that on the SBC page and started looking more at other events. So what I did is I wanted to reverse engineer that tornado outbreak scene. And I just kept it more of a simple kind of, overview approach, just looking at the jet stream patterns and looking for any tendencies that I would find from all the outbreaks. So the timeline, I started this in 1950 is where the database starts, and it goes through 97.5. Through 2000, all the way up to currently 2025. So that's the research timeline that I looked at for all these violent outbreaks. So it was a quite large Excel database that I had one of my coworkers help me build, and it was utilizing all the SBC tornado stats. Very large database, but I needed to parse it down a little bit to make more sense of it. So this is what I did. I had to draw a line in the sand, but it kind of fell out of the data when I was looking at the data. And this is the line in the sand where I drew for an outbreak, 3 to 5 long track, strong to violent tornadoes. I would call that an outbreak. And then for violent outbreaks, I had at least 6 or more long track EF2 to EF5 tornadoes, and I called that a violent outbreak. So those were the lines in the sand. And as we go through the data and I show all the charts, you'll see why, those are pretty defined lines, and it was kind of interesting to me. So long track tornado, I called it a long track tornado if it had a path length of at least 15 miles or longer. That was considered a long track tornado, and that's what made the database, and everything less than that, I would just skim over and toss out because I just wanted to capture more of the higher end events. And then for each one, I calculated the number of long track tornadoes, again, looking at EF2 or stronger. And for each event, I just tallied up the numbers. So once I did all that, I looked at the jet stream and I looked at the jet stream alignment for each single event. And I was looking at it from a pattern recognition standpoint and trying to find, is there any fingerprint that Mother Nature is throwing at us for these higher end events? And once you look at enough of them, something started to reveal itself. So here are the numbers. Out of all the events that I looked at from that period from 1950 to 2025, I discovered 83 violent outbreaks, 182 outbreaks. So I had 265 total outbreaks that I looked at and diagnosed the jet stream and tried to throw all the math at it. So we typically, the math works out, we average about one violent outbreak a year, and then outbreaks average about 2 to 3 per year. So they're pretty rare events, especially the more violent outbreaks. So this is where the gray area begins, is analyzing the jet stream, which quadrants you're in. It's kind of that gray area. But there is enough information and enough pattern recognition that I was able to parse out, what's going on, how the jet stream alignment in which quadrant is influencing mainly the warm sector. So looking at the outbreak, this is all the data where I had at least 3 to 5 long track tornadoes, 15 miles or longer, and these are the jet stream alignments, and you see all the numbers there. They're kind of all over the place. It's not a very good signal, but there's information as we go through other charts. I'll show you how helpful it is. I would call this signal more on the mild to / moderate signal for these outbreaks. But when you switch over and just pinpoint the violent outbreaks, one thing was pretty glaring. It really jumped out was this orthogonal, I call it this orthogonal jet stream alignment. It had a very strong correlation for the violent outbreaks when you go back and look at all the data from the past history. I found this research paper. This was done in 2009. This is an oldie but a goodie. What this basically summarized was tornado report frequency increased dramatically when the jet stream angle was between 210 degrees and 270 degrees. No surprise, we get a little bit more directional shear when that happens, but it was good to see this paper. I started all my work in 2011. I had no idea that this paper existed. I stumbled on this a couple years ago, and it actually kind of validated everything that I was looking at and finding throughout my research. And this is what I found, is that this orthogonal jet stream alignment was happening so frequently at a high correlation for all these violent outbreaks. I decided to give it a different name just because we're all about acronyms. So I called it the VOC, the Violent Outbreak Cross, and that's that orthogonal breach of the jet stream exit region into the warm sector, usually across the dry line or cold front, and usually it's going to be 100 knots or stronger in that jet stream core, and that alignment was definitely, fits that research paper, was always in that 210 to 270 degree angle. So here's the data, jumping in the data. Again, we had 83 violent outbreaks, 182. That each dot represents both the violent and the regular outbreaks. And what we're looking at on the chart on the left side, this is the total miles for each event. I looked at all the numbers of the long track tornadoes, added up all the miles of those long track tornadoes, and then on the bottom was the number of long track tornadoes. And this is where all the data plots fell out, and I started at 3 and continued on. And if you look at some of the more historical dates, they're kind of labeled there. And if you see something missing, where are the super outbreaks? They're not on here. Yes, they are. I just got to expand the chart. They're way off the chart. When we're talking about stuff off the chart, these 2 events were definitely way off the chart. With April 27th having 39 long track tornadoes and April 3rd of 74 having 58. So those were just extremely rare events, those super outbreaks. Let's dive more into the data. So now all the dots, I'm going to change the colors here. All the blue dots represent the violent outbreak cross, and then all the red dots represent the non-violent outbreak cross, or the non-VOC. This had some different jet alignment, whether it was upstream meridional, or the right rear quad, influencing the warm sector. Now, if I move forward and change the line in the sand, and if I go to 6, there is a noticeable correlation going on here that the VOC alignment for these higher end historic events just really shot up once we got to 6. That's why I started the violent outbreaks at 6, because of the high correlation. Yeah, there's a handful of non-VOC where, we're meteorologists, we're looking at Mother Nature. You do get into gray areas being a meteorologist. It would be nice if you had certain things that would just align itself black or white, but I felt this was a pretty strong correlation, and when you throw some numbers on it, it definitely jumped out. Some more recent events, the March 31st of 2023, this actually ranked 7th all time on the list for most historical violent outbreaks, and that was kind of interesting to see that one. And if I look at some more data, just this past year, March 14th, 2025, I don't know if many people know about this one, but it was the 4th highest all time. They had 732 miles of long track tornadoes that were on the ground. I mean, it was a pretty prolific event. There wasn't as many deaths, which we're thankful for, but it was a pretty prolific event when you look at it from a pattern recognition standpoint. And if we look at what happened this year, we actually had 4 violent outbreak events. April 2nd, March 15th, and May 16th, all appeared on the scope just this year alone. The last time we saw this type of frequency was back in 2011, when I think we had 3 violent outbreaks, and this raised the bar even higher. So it was an extremely busy year for us this year across the CONUS, especially east of the Rockies, where all this happens. So here's some more charts and data. This is a jet stream alignment percentage and the number of long track tornadoes. So the orange line is the VOC, and then you got your long track tornadoes on the bottom. And then the blue line represents the upstream and upstream meridional and the right rear. I kind of threw those together. You kind of get into some gray area, a little bit of overlap between 3, 4, and 5. But once you get to 3, it starts to separate. And then something really interesting happens once you get to 6. It just surprised the heck out of me, is you get this flip. I mean, it is a noticeable flip when you go from long track tours from 5 to 6. And if I carry that out, it doesn't change that much. It pretty much flatlines. It's a very high correlation. And if you get to 11 or more, then the signal is pretty much 100%. Now, there's not a whole lot of events that go beyond this, but every one that does, it was all the VOC alignment with the jet stream. And if I extend this all the way out to the super outbreaks, sure enough, those were on there as well, and it kind of just squashed the data. But very strong correlation. Once you got to 6 or more, on those number of long track tornadoes. So I also looked at the number of EF2 tornadoes to EF5 tornadoes without looking at the track path length and seeing if there was any information there. And sure enough, it kind of followed the same pattern. You get into this gray area, it's separated between 5 tornadoes and less. It was definitely the VOC alignment was less, it was less common, but it definitely ramped up once you got to 11, when you get to 62% to 12, and then that carried out just like the other one. But you do have this gray area, but majority of the time, probabilistically, it was more of the upstream and the right rear having a higher tendency from that 5 to 10 number of EF2 to EF5 tornadoes. So that was some interesting data that fell out of all these events. So some of the key takeaways, when you look at all of this and you look at the jet stream alignment for all these bigger events, a notable probability increase for number of long track tornadoes was at that threshold of 6 or greater, and the number of EF2 to EF5 tours with a VOC alignment, I call this like the high alert. If you have the VOC alignment, you definitely want to pay attention and have a more high alert that this could potentially lead probabilistically to a high-end violent outbreak. The upstream meridional alignment had the lowest percentage, and there was no violent outbreaks with that type of jet stream alignment. The right entrance alignment had the second highest probability, followed closely third by just the upstream probability. So this was some of the key takeaways that I mined out of the data that starts to make sense and help us from a probabilistic standpoint, just looking at the jet stream and looking at the tornado environment, if we're expecting tornadoes that day, to kind of give us a feel or gauge at how big this event could potentially be. So we looked at the jet stream alignment. Was there another signal that I found? And there sure was. If you look at the research data, the relationship of low-level instability and the tornado damage rating based on observed sounding. So yeah, big crazy numbers, all the parameters and everything. I'm just going to skim through this a little quickly, but they noticed that there was minimal utility in discriminating the violent tornado outbreaks with the shear, your mean LCLs, the SIN. There was a lot of overlap, so those weren't very useful. But what was more useful was CAPE and instability. The component of STP was a better discriminator of these violent tornado outbreaks. And if you look at low-level instability, low-level CAPE, low-level lapse rates, it definitely showed a little bit more skill and a little bit more separation, a little bit less overlap was the instability. So the question I ask is there anything we can observe over time that might cause a contributing increase to low-level instability? Because it's not like you can measure wind shear and calculate that and measure it from day to day. That's not going to make any sense. There is something. And I found a little research is soil moisture. And what it does to the surface energy balance is you get a bunch of precipitation over the area. It creates a little evapotranspiration. Key takeaway is above normal precipitation leads to higher boundary layer theta E, which ramps up the instability and increases the low-level CAPE. So just in the simplistic approach, violent tornado outbreak, we know that they typically have the lower LCLs, and it has these higher values of low-level CAPE. So if you have moist soil conditions, like for example, 75/67, we know that that LCL is going to be lower. We're going to have higher low-level CAPE opportunities compared to dry soil conditions. your LCLs will be a little bit higher, and you probably in your values of low-level CAPE will be dramatically reduced, or you might not have any as well. So what components of STP and VTP are sensitive to instability changes when we look at these formulas? I'm going to mine those out. These are the components, and they carry a lot of weight in the STP and the VTP, but these are sensitive to instability. So this is what I did. This was I did not run this from 1950 all the way up to current. This period goes more from 2000 to 2014, and I'm in the process of updating, and I've looked at current events just sporadically, and sure enough, the signal stays pretty consistent. It just takes a while to compile all the precipitation data, especially once you get, you know, prior to 2000, because it's pretty hard to find the data. It's when you get into those older periods. So this is what I did. So for each event, I went back 12 to 14 days, and I looked at if it rained 1/10 of an inch or more in the affected area by the outbreak. I called that a rain day, and I calculated all those up, and then I tracked how much precipitation fell over that area or in close proximity to the affected outbreak locations, and kept track if it was above normal or below normal. So this is all the data looking. So the outbreaks and the violent outbreaks. So each dot is an event, and the colored dots, the green ones, is that event had above normal precipitation, and all the red dots had below normal precipitation. And you notice some pretty high correlations going on here between the outbreak and the violent outbreaks. For the outbreaks, only 50% of the events were above normal, so that means 50% of the outbreak events were below normal. So from a meteorologist standpoint, that's not very helpful. We don't like 50% values. We like a much higher probability number. And when we switch over to the violent outbreaks, it takes a number that really catches my attention, is 88% above normal for these violent outbreaks with the standpoint of precipitation. So if I draw a line and we just look at days, how many days it rained during that 12-day period of 6 or more, on the outbreak side, didn't really change the numbers a whole lot, still around that 50% mark, but the violent outbreak, just a little uptick from 88%, but pretty strong signal, stayed pretty similar, it was 90%. So what was going on? It was an active weather pattern. So these violent outbreaks are not just coming and falling out of a quiet weather pattern. There's usually active weather. We're getting a lot of rainfall and probably a lot of severe weather in the area. All of a sudden, the jet stream realigns itself and becomes something more ominous, like the VOC alignment, and it kind of sets the stage. So you can kind of pay attention to precipitation to see if something could be brewing on the horizon. Now, does that mean if you have above normal precipitation that you're going to have an violent outbreak? No, it does not, but it's just something to keep, you know, in the back of your mind, kind of awareness signal that Mother Nature might be kind of setting things up for something bigger to happen. So I'm just going to go through these pretty quick. These are some of the more historical outbreaks, and you can see the precipitation the 12 days prior to the outbreak, and you notice it was well above normal for this particular outbreak. And I'll just kind of step through these. The Palm Sunday, the big super outbreak. This was the Heston event. It was kind of interesting to see that these were also high precipitation events, you know, leading up to these violent outbreaks. It was a very moist and active pattern, which increased that soil moisture, low-level instability, and lowered the LCLs, which kind of primed the stage for something a little bit bigger. Well, now let's do some comparison. Some of you might remember this, the May 20th of 2019 was being compared to the April 27th of 2011, but there was dramatically different end results. And this is where the gray area continues. So both events had a high risk. If you look at the shear, lots of shear, pretty much orthogonal to the initiating boundary, 50 to 70 knots in the 2019, 60 to 80 knots in the 2011 event. Lots of instability, uncapped, STP off the charts in both cases. So just looking at that, as a meteorologist, we know that that's a very volatile environment for tornadoes. Looking at the soundings even looked eerily similar. So everything we know, if you're comparing this, is like we should expect the same thing to happen on May 20th, and that was what the outlooks were looking for, was this could be a potentially bad day. And this is not to, discredit SBC or anything. They do a fabulous job with their outlooks. We're all meteorologists. We all get humbled, and we get into these gray areas, and it's a challenge. Is there something else we can look at? And if I throw the upper level jet stream, because we have very similar tornadic environments here, if I throw the upper level jet stream up, it will show something drastically different. Here's the numbers. Here's the number of strong to violent tornadoes. Completely different, where the May 20th was considered a bust. It just didn't pan out like we thought. And you just had just a few strong tornadoes, and they were pretty short track compared to the April 27th. Both environments were very similar. Now, if you look at the upper level jet, vastly different. April 27th had that strong VOC alignment, whereas the May 20th, 2019 had this non-VOC, that upstream meridional. And when I looked at all the upstream meridional alignments for the jet stream, none of those ended up going on to be a violent outbreak. So parameter space doesn't count for the upper jet angle. It can't see it. It doesn't know which quadrant you're in. So use that as a word of caution. The parameter space does an excellent job of diagnosing the environment's tornadic potential, but how it's going to unfold or be unleashed, there might be something to this jet stream alignment on if this is going to be a bigger event or not. Let's look at some more comparisons. This was back in 2017, May 18th. I'm just going to kind of scroll through these. And we were dealing with this. I was like, man, this could be another big day for us. So here's the environment, lots of instability, uncapped, STP, favorable values, 5, 6, everything we look for a highly, favorable tornadic environment, lots of shear, pretty much orthogonal and perpendicular to the dry line. Here was the upper jet alignment. It was a non-VOC upstream meridional alignment. You didn't have that orthogonal breach of the exit region into the warm sector. And here is the end result. They just had 3 EF2 tornadoes, and they were shorter tracks. So another comparison from this year, March 14th and March 15th, 2 very high-end days, very busy pattern earlier in March for tornadic activity. And we'll go through this quickly. Both of them, lots of shear, pretty much orthogonal, 50 to 70, 80 knots, instability, not quite as high, but still lots of instability, very favorable environment for tornadic supercells, and very high STP values. And if we look at the numbers, the March 14th, this was number 4 all time for violent outbreaks. It had 21 long track tornadoes, 732 miles for all those long track tornadoes for that particular event. And then the following day was another busy day. The numbers weren't quite as high. You had 10 long track tornadoes and 274 miles. It was still a violent outbreak. It was just not one of the higher ends. Now, if we look at the jet stream alignment, This is the 12Z setup. And if we just focus on the March 14th, I'm going to toggle back and forth between the 12Z and the 0Z. And you see the orthogonal VOC shooting across the initiating boundary into that exit region, shooting out into the warm sector, where you had something a little bit different on the March 15th. The tornadoes were still happening in the late morning, early afternoon. It was transitioning out of that orthogonal VOC alignment in the morning, more into this right rear quad alignment. So the 14th had the VOC alignment. The 15th started off with the VOC alignment, then transitioned out of it into the right entrance region. Still a big day, and high risk was definitely warranted for that day. But it's just something to kind of note. We kind of get into some of these hybrid events where it could start out as a VOC and then transition to something else, or if the event starts out as something a non-VOC, the potential numbers, from a probabilistic standpoint, are usually down for that event. I'm going to do one more last comparison. This was March 31st of 2023 compared to April 4th of 2023. And the numbers were dramatically different on number of strong to violent tornadoes and the path lengths, because March 31st, 2023 was 7th on the violent all-time outbreak list. So this is how the jet stream alignment unfolded for both of these events. You had the strong VOC alignment for March 31st, and then the April 4th, you had this non-VOC, this upstream meridional alignment, which typically, yes, you can still have tornadoes, and I don't want people to say, oh, we're not going to have tornadoes today. You're just not going to have the probabilistic standpoint. You're probably not going to have the big numbers of tornadoes and number of long track tornadoes. It's more going to be reduced compared to a VOC alignment. So this is a AWIPS procedure that I have at the office. A few folks have copied this, and I'm more than happy to share this with others if you would like this. It's a very simple 4-panel, but this is how it looked on the April 4th. And this was a 36-hour forecast before the event folded. And if you look in the top left, you can see the upper level jet alignment was that upstream meridional, not that orthogonal breach out into the warm sector. And as you look at the 4-panel, it was a lower end event, tornadoes, but it wasn't the big violent outbreak. And then if you look at the March 31st, I think I have a loop here that might run. This was 40 to 36 or 39 hours before the event. This really got my attention that, that region, that part of the country could be looking at a high-end event, just looking at it from a probabilistic and a pattern recognition standpoint. So in summary, we're meteorologists. Anytime, we're trying to, do these forecasts for these violent outbreaks, we're going to run into these gray areas, and sometimes they're going to be large. And by doing this research and looking at research papers of others and utilizing SBC's outlook and their expertise, it's all about trying to make things better, learn from each other, and try and minimize that gray area and come out with the most highly, likely outcome from a probabilistic standpoint. So where all this comes in from is what I'm asking folks to do is continue to do your progressions of the tornado environment forecast like you always do. Is there a VOC alignment or not, or is it a different jet stream alignment, precipitation signal? Have we been in a wet pattern, active pattern leading up? And if you add all that together, it should give you a little bit higher probability of how the event might unfold and improve your prediction. Could this possibly be a rare violent outbreak or not? from a pattern recognition standpoint. Some of the future work that I want to do with this is we see these charts in our trigger charts, and it's a very neat matrix from a probabilistic approach, and I want to kind of mimic that and apply all the math and the data from the jet stream to that and figure out when's the time when we really want to pay attention for these high-end, high-risk days where a violent outbreak could happen compared to those days where it might not be a high-end event, but more an outbreak event. And that's some of the future work that I would like to work on and try and put some more probabilistic data. So what about null cases? I hear this, and this is always going to, be I want people to shoot bullet holes in my research and everything, because this is how we learn more, because there might be some things I haven't thought of. And I want people to ask questions, have you thought about this or not? The null cases are kind of hard because it doesn't make the database. Nothing really happened. It wasn't a big tornado outbreak, so nothing happened. I don't know what the jet stream was doing, so that's kind of hard. So the only way to kind of start compiling and looking at null cases is I have to be looking at the jet stream almost daily during our peak tornado season and see if the alignment is happening and how the event transpires. So that there might be some null cases there. I mean, we're in meteorology. We just don't know. But I need to know that data, and that's the only way you improve the research. So that's all I have. So I'm open for any questions. I'm going to stop sharing my screen here, and any comments. If you want to shoot any bullet holes at any of the research, I'm all ears. I'm definitely open for suggestions and comments.
Thanks so much, Chris. And I love that you were able to grab some cases from this year too. That's fantastic. If anyone does have a question, feel free to raise your hand, type it in the chat, or just chime in. Go ahead, Aaron.
Good morning. Hey, great talk, Chris. Appreciate you digging into some science here. A lot of this reminds me of I think it was Greg Dial back almost 15 years ago, when he's at SPC, did about alignment, and some of this you see in our mesoanalysis training and such, but analysis of, alignment of a boundary versus the mean cloud layer winds. And, makes logical sense that if you have more of a, say, a long component, so in this case, the jet stream is more parallel to, say, a front or a dry line, it's going to be harder to get sustained discrete convection that you need for these long duration supercells, versus if that's cutting directly across the dry line, you can maintain that discrete mode longer. So it kind of makes sense with the alignment of the jet based kind of what you're seeing plus what Greg Dial's research shows. So some good stuff that really can help. The cams will show what they're going to show, but it helps you kind of differentiate the noise from the real events. So anyway, very good. Thanks, Chris.
And great. And thank you for those comments and everything, and for sharing that, Aaron. Yeah, this can be kind of one of those big pattern, recognition, Yeah, like on the May 20th of 2019, yeah, we were expecting a big event. The HER was going off the charts, with its projection and everything, but you can kind of step back and look at the big picture, bring that into the equation. It's like, okay, does this have the potential to match up with what some of the cams are showing? And to expand on what you commented about, Aaron, you notice in those events, when you look at the wind shear, it was orthogonal. It was more that west to east orientation, even though the jet stream alignment and how it was interacting with the warm sector was different. And that's another important nugget that I pulled out of this data is you definitely want to pay attention to that upper jet, because like you said, as we know, if you don't have that alignment of the jet more orthogonal, to create that discrete mode, if it becomes more meridional, your tracks are going to be shorter. The probabilistic chances of those long discrete cells goes down dramatically, and the event might not unfold as big.
Awesome. And I see we have a comment from Suzanne asking about sharing the procedure with the forecasters at Omaha possibly, and also asking for how this has been included in RMA. And not directly, Suzanne, but we could for sure share this research and this presentation with our RMA facilitators as well. I think there'd be a lot of interest. I see a few of them on here, but as far as the entire group, I think that's definitely something we could share.
Yeah, if anyone would like the procedure, I can get together with one of my coworkers. He can help me bundle it up. If you fire off an email, and I could send it out to folks that would like to have it. It's pretty simple, and I love building procedures, playing with all the vibrant colors to point out things of interest.
All right. Any additional questions for Chris? Just a comment that it'd be interesting to include some before 1950 as well. Yeah, I know the data are pretty scarce back then, but it would be interesting to see some of those.
Yeah, that link on the SBC page, it does have some more of the historical events, and I looked at some of those, and yeah, there was pretty high correlation with some of those. But once you start getting beyond, 1950, it's like, yeah, it's pretty old stuff, and we don't have a lot of good data back then. But I feel the period that I looked over, I mean, that's a pretty long period, and the signal it's a pretty strong correlation.
All right. Any last questions? If not, thank you so much, Chris. This has been fantastic. And thanks everyone for joining and participating. This will conclude our Innovation Spotlight for today. And we look forward to seeing you all again soon. Thanks again.
All right. Thank you, everyone. Again, just email me if you have any other questions.